Good afternoon, dear teachers, students, and attendees. And for those of you who have not had the privilege of meeting, my name is Molebatsi Matshana, and as obvious as it is, I stand here today to present my grade 11 project. Without a doubt, it's turned out to be quite the year. Very few people had the foresight to see a year like this coming, and we had no way to prepare for it. And yet, we persisted. So well done. This year, we all demonstrated rare leadership qualities and were able to complete our projects, and here we stand. By this time, I was hoping to have my braces off, just so I can smile as I deliver a hopefully good speech. But alas, that didn't happen. Just as similar to how I didn't always stick to my project deadlines. Thank goodness for the extensions. However, it wasn't always like this. I did start off good, and once set sail, it was an experience like no other. We always knew this day would come, where we'd hear our guardian suggest us to start thinking of project ideas that we would undertake for the next 13 months of our lives. Immediately, I knew what I wanted to do. I knew the top 3 picks that would be chosen by me. As soon as I had the time, I wrote drafts after drafts of what project best suited me. They all particularly related to science in some shape or form, but there was one I've been longing to do and decided the grade 11 project was a good excuse to finally do it. Additionally, I wanted to keep the theme of my high school projects the same, and so I set my year 11th independent research project on climate-controlled environments. Well, that's what I officially agreed to myself 2/3 of the way through. Before that, I constantly needed to adjust the answer to every inquisitive person who asked, "What exactly is your project?" Now that I finalized my project, I can properly explain what I worked on without having to improvise an answer. The central focus of my research was the technological advancements made in the field of controlled environments to better fit our needs and the needs of those around us. From the early cultivation of plants to synthetically creating climates that mimic regions on Earth. I spent a large majority of my research designing my own table-sized plant grow chamber. These chambers are simple concepts. There are specialized types of environmental test chambers which are designed to perform growth for optimal conditions, usually for laboratory testing. In the early stages of my research, I had no shortage of passion, excitement, and drive. Key feelings that allowed me to complete sections of my project well ahead of time. Being so ahead of schedule, I couldn't help but feel a little proud. Unfortunately, not for long. The moment was short-lived, and towards the end of the project, months turned into days, days turned into hours, and in those hours, the upcoming section of my project was due, and I only had 2/3 of the work done. I don't recall another time in my short history that I have worked so hard to complete something in so little time. I say it again, thank goodness for extensions. Like any amateur coder, I believe the most difficult part of my research would have been further developing my software engineering skills to extend to my project's needs. In the end, that proved to be the least troubling hurdle in the race. No, the hard part was writing a script, then psyching myself up to call a manufacturer to assist in providing the necessary materials for the project. In the end, it was not as bad as I played in my head. I could have made the growth chamber in dozens of ways, but it quickly became expensive. Additionally, I wanted to keep the concept simple and autonomous. Plant growth chambers vary from one form to the other, depending on several factors, from optimizing energy efficiency to experimenting with new hybrid environments. There are, however, key components that are crucial to have in the system. So, I want to take a small theoretical journey with you. Let's walk together and construct a plant growth chamber. We have ourselves needing to find a way to protect an organic plant, so we construct a fully enclosing the plant. Although a fully enclosed environment does protect the plant from exterior elements, It will succumb to death without substitutions from sunlight, water, and airflow. Our plant is in no way an ordinary. However, this is really awesome because at least now we know what are some crucial factors into the project. In any project, we know we're getting somewhere if we run into challenges, because challenges create drives, and drives create problem solving. Now let's try and mimic the sun. When it comes down to synthetic lighting, there's a variety of different options which are better at handling different tasks. White light is found to help in leaf growth, whilst blue and red light stimulates flowering. Recap: external protective barrier, check. Fake lighting, check. Water for our high maintenance plants, it's a fairly straight concept. Water, pump, tubing. A bit of creativity and we're 2/3 of the way there. Depending on whether we wish to make the plant chamber semi-portable, which we will then store the water in an internal chamber, meaning we need to redesign the chamber to have a storing section and locate a pump in additional section, as well as connecting these sections with tubing, which will allow the water to move through sections from sections. Alternatively, a stationary chamber allows us to store water in an exterior storage and have the piping transport water into the system. Take a deep breath. We're almost done. At this moment, we have substitute lighting system and a watering system, as well as a simple ventilation system, which flows from the upper chamber and makes its way to the bottom chamber, where we will place a fan to allow gases in the chamber to expel outwards. This is simply to avoid high levels of humidity as well as control the circulation of air. The last thing to think about is the system's waste. It may not be as foul as changing diapers, but if left unchecked, it might as well be. So, we must avoid a clog at all costs. We need to place a waste system to remove, so we can simply use gravity as our support. Waste, in the form of liquid, will flow out of the bottom chamber with carefully made separation valves. With all of our components set but unresponsive, we need some electrical skills to understand how to best wire the system and connect to the exterior chamber that houses the control modules. Here is where we have the chance to automate the system using microcontrollers from boards like Arduino, BeagleBoard, and Raspberry Pi to control the internal components. This allows us to control modules whilst other modules remain on and off as the many different variations between the two, including an internal clock to fully automate the system. Think of this component as the brains of the operation. Well, this is more or less the oversimplified breakdown of a plant growth chamber. More thought generally goes into it. For instance, choosing the material of the tube and chambers isn't as easy as picking anything off the shelf. Under normal circumstances, we would pick something that doesn't allow for natural light to enter the system, since we're dealing with moisture or organic substances. And if light enters the equation, it's a recipe for cultivating foreign organic substances. In the event that you do not enjoy frequently scrubbing moss down, I'd suggest using the proper materials. Though this isn't the state-of-the-art winning design, in fact, some might call it the state-of-the-art expensive junk, perhaps my sister, but it removes several issues of growing plants outdoors, where the environment is unviable. Far more advanced systems are capable of delivering more and reducing the growth time, and improves the quality of the plant. So why all this trouble and money for a glorified plant pot? Well, humanity. We managed to continually revolutionize methods that existed in previous generations. As abnormal and twisted as it sounds, manipulation of our environment is not a recent event, nor is it as ungodly as it sounds. Early humans have explored the nature of manipulating their environment to best suit their needs. As early as 9,500 BC, humans took what naturally grew around them and made it their own. Today, we not only have the technology to manipulate the world for our needs and desires, but also the needs and desires of all the Earth's inhabitants, so that we remain at a point of equal balance between giving and receiving. Without this balance, the scale tilts, then falls, along with the order of all things. As a species, the miserable reality is our vision only extends to the bridges of our noses. We simply only react to the forthcoming disaster once it's upon us. In life, there are no right or wrong answers. There are only trade-offs. Sooner or later, our current methods of living will no longer be viable for sustainability, and it's now that we have the option to develop research into more sustainable resources before that scale tilts. This project wouldn't have been possible without my mother, Jill Sissoko, and my internal mentor, Ashley Chamberlain. So I'd like to end my speech by thanking them and welcoming our next talented speaker, Matshana Govender.